And more companies are building these AI and machine learning models and using large generative models as well as the classically trained regression models or identification models. And the problem with this is the expectation to just keep going faster and faster. AI is moving at a breakneck pace. I want it trained, I want it yesterday, I want it now. We're sometimes skipping these early layers and skipping that crucial phase of determining if the data is right before you go in. And sometimes it's not enough to just determine if the data is right, like if it's all there as it should be. Sometimes you have to determine if the data is correct, which is a bit of an odd way of thinking about it. You don't necessarily want what you have in production to be always what you have in production. You don't want to perpetuate that bias that you have today. Sometimes you want to ensure that the gaps, certain, I would call them equivalence partitions because I come from a testing background, but those kind of intersections of variables, that they may not be there in production, but you want to inject them into your data pipeline. You want to synthesize them, or you want to counterweight lack of data so that you don't end up with situations like that product problem where mirroring exactly what is today is not the desirable situation in the future. So talking about some of the things that can go wrong in data integrity pipelines. Alex, have you seen a couple of examples of situations where people have run into problems with their DI? No, there wouldn't be any, right? It's never happened.
So I've actually, I think, been fairly lucky in that I've actually seen things go spectacularly wrong, but I've also been involved in some fantastic projects where we've caught things before they've gone spectacularly wrong and been able to actually remediate them. So let's just say I've had the best of both worlds, where I can see what happens if you don't catch it and what happens if you do catch it. And it's a pretty stark difference.
I think I've also seen it go wrong in terms of AI training. A great example, actually, from the early days of Tricentis was we were training this network behind Vision AI, and we weren't doing proper data science. We were in kind of iterative startup, go fast mode, and we trained it on normal screens. Long story short, it turns out that there's a lot of text and a lot of icons in any given screen. And so it had really high accuracy, and we rolled out this first version that's like, well, pretty much everything's text or an icon. That input, it's probably an icon. That button's probably an icon, because it just sort of had that internal bias. And we had to spend a lot of time counterweighting and retraining, and burnt a lot of rubber, so to speak, in finding the right way to polish the input data to make it look more like what the desired state would be. Kind of really wish at that time we had have gone back and said, no, before we start training, let's look at this data, holistically. Let's apply proper, DI practices to it and make sure that it's not only correct, which some of it wasn't, but that it's representative of what we want in the future. And this kind of gets interesting as modern organizations are picking up faster and faster changing data pipelines. I think you've seen some of this in the industry, Alex.
Well, I think when it comes to sort of data integrity or data quality, there is three things, or three sort of universal truths that we have to deal with. So if we go back and consider, why do we have data in the first place? Why are we collecting the data? Right? We're not doing it for fun, although it can be fun just to see how much disk space you can consume with the stuff that you're collecting. The question is, the data you're collecting is there for use, right? It really doesn't. You could argue that it doesn't really exist until you use it, because it could be, it could be all null values, it could be all rubbish if you never use it, and who cares, right? It's taking up disk space. Congratulations, I've got that data. It doesn't do anything. But the three main challenges that we're seeing is the data is increasing, the data is moving, the data is changing constantly. Now, sometimes I sort of refer to this as more moving and changing, but to be polite here, I'm going to use the word increasing, right? So if we think about the fact that data is increasing, what does it mean? It means that our systems are getting bigger, more complex, more interconnected. There's more systems being connected to other systems. They're producing more data, which means we're consuming more data. So in short, businesses continue to generate more data. We used to have disk space at a premium. We used to do everything to be super efficient everything that we store. These days, disk space is cheap. We can store everything. We can just grow our S3 storage to near infinite levels. Now, that obviously presents a problem if you have constantly more and more data, right? One of the sort of first problems you hit is typically the system that is actually generating the data isn't the system that's actually analyzing and reporting it, right? That's typically done by another system, and your data gets passed to it, gets moved around. And as organizations get large, you typically have multiple systems feeding a single sort of reporting or single analytics system or single warehouse system. And of course, different systems. Here on the slide, we have Salesforce and SAP. Now, if my company has both Salesforce and SAP and I want to be able to report on it, I can't just do a straight copy of my data out of Salesforce, my straight copy out of SAP, and expect it to provide meaningful results. I need to be able to transform that data into a common state where business terms and analysis are actually sanitized, so they're actually meaning the same thing between the different systems. So that means we have to do these transformations of taking data out of the source system, moving it to a data warehouse, and we're changing the data in that transformation. So, we've already started saying, great, we've got more and more data, and we're constantly changing and transforming as it goes forward. But it's not just the data that's transforming, right? It's not just the data that's actually changing. It's not a one-off event. It's something that keeps going over and over again. And while it's going, your entire system, your entire environment is also constantly changing and evolving, right? From an application level, new tables are added, columns are added, columns are changed. But the application itself is being updated. Various APIs are being updated and changed and modified. Your network infrastructure is constantly being updated and modified. And, it doesn't take you very long to realize just how many cloud downtime has just been caused by a simple DNS failure. It's always DNS, quite frankly, when you look at cloud failures. But, jokes aside, we're living in a world where we have ever-increasing volumes that are constantly moving on an ever-changing platform. The question becomes, what could possibly go wrong with that system, right?